Video is on integration using residues. In today's video, we are going to solve a problem related to residue theorem. So in this video, we are going to evaluate integral cos pi z square by z minus 1 into z minus 2 dz, where c is a circle, mod z is equal to 3 by 2. So clearly it is given that integral f of z into dz is given. So our f of z value is nothing but this is cos pi z square by this is z minus 1 into this is z minus 2. So in order to find the poles, what we have to do? So we have to equate the denominator to 0. So if I equate the denominator, that is z minus 1 into this is z minus 2 to 0. See here, first of all, if I equate z minus 1 to 0 and next z minus 2 to 0, so we got z is equal to 1 here and z is equal to 2, which are simple poles. So these are simple poles. So here z is equal to 1 is a pole which is simple, and z is equal to 2 is also a simple pole. And here our circle is given as mod z is equal to 3 by 2. So what does it mean? So it is a circle with center 0. So this is a circle with center 0. And if I cancel, this is 1.5 as radius. 1.5 as radius. So this is the circle. This is 0. This is 1. This is minus 1. So if you observe, this is plus I and this is minus I. And see, this will be 2. This is minus 2. So this value is minus 2i. So this is plus 2i. Plus 2i. Clear? So in this, so 1.5 is in between this one. So this one. So this is 0.5 and this is 1.5. So here this value is minus 1.5. Here this is I is equal to, so this value will be 1.5 into I. So this value will be minus 1.5 into I. So in this, see here, this is a circle. Z is equal to 0 is a circle with 1.5 as radius. So if you observe this one, Z is equal to 1 is within the circle and Z is equal to 2 is outside the circle. So we have to find the residue at the point Z is equal to 1. So in order to find the residue of f of z at point z is equal to 1, so what is the formula here? This is limit z tends to 1. This is z minus 1 into f of z. So this value will be limit z tends to 1, z minus 1 into f of z. What is our f of z value? This is cos pi z square by z minus 1 into this is z minus 2. So if I cancel this one and substitute 1, so this will be cos pi by 1 minus 2. Cos pi value is minus 1 and this is again minus 1. The value here is plus 1. So we got the residue of f of z at point z is equal to 1 is 1. Therefore, according to our residue theorem, what we have to do? According to our residue theorem, so this value is equal to 2 pi I into sum of the residues of interior poles. Sum of the residues of interior poles. That is according to this theorem. So integral f of z dz is nothing but 2 pi I into the residue value here is 1. So the value here will be 2 pi I. So this is how we have to solve. This is also so simple. Here f of z is given like this. After equating the denominator to 0, we got z is equal to 1 and z is equal to 2 are the two simple poles. And here the circle value is given as mod z is equal to 3 by 2. So which is of radius 1.5 and center 0. So this is 0 with 1.5 radius. I have drawn a circle. So 2 is outside the circle and there is no need of calculating the residue for this. Only z is equal to 1. For z is equal to 1, the residue value is 1. So according to our residue theorem, integral f of z dz is nothing but 2 pi I into sum of the residues. So 2 pi I into 1, which is equal to 2 pi I. Thank you so much for watching.